Chapter 6.3, Method of Sections. This is example number 2. We're looking at problem 6-45 in the book. They give us a standing truss. It looks like we're solving for members BF, so I'll go ahead and highlight them again. BF, BG, and AB. So those are the three trusses, or the three members that we will be looking at solving for. Now, let's take a look at member BF. And let's go back and think about our method of joints. And if we cut this like so, even if we said method of sections, we just cut three members. And let's go ahead and draw that free body diagram. Noting that all of them are in tension, and this is joint F. So let's just say that we are looking at joint F, and I know we're doing method of sections, but let's just take a look at this real quick. Now, if we summed our moment, let's label these real quick. If we summed our moment let's take a step back. Sum our forces in the x direction. What do we got? Well, we got BF and nothing else. So BF is equal to 0. This is a zero force member. So anytime you see something that looks just like this and they're asking you to solve for a force in this member and has nothing over here, you know it's a zero force member. You automatically know that's a 0. Even if there is a force acting here, if I take my force about that joint, I know it's 0. Now let's go ahead and do the method of sections to solve for BG and BA. So I will be cutting this like so. So the first thing I'm going to do is I'm going to draw my free body diagram. So I'm going to try really hard to make this as straight as possible. And I draw them in tension. Let's go back and label these. This is D, this is C, this is E, this is B, this is F, and I could finish these with dashed lines and label this as G and label this as A. Now let's go in and put the loads that are already on this truss. We have 3 loads here. This is 5 kilonewtons. This is 10 kilonewtons. And this is another 10 kilonewtons. And then we have a 5 kilonewton force here. And that's all we have except for our distances. So this would be 4 meters, 4 meters, and then across here, from here to here, is also 4 meters. Now, we could have done the free body of just the bottom piece. Solving for our forces that we're looking for. And I could finish these with our dashed lines. And this is 4 meters. And this is also 4 meters. And this is BA. And this is BG. And this is FG here. The other thing that we're going to need is AX. I'm sorry, that's AY. And this is AX. And this is GY. So, in order to use this free body diagram, we would need to compute our reaction forces. So there's definitely that route that you could do, or you could come up and use this free body diagram without having to compute the reaction forces. Now, if you're going to use the reaction forces remember you solve those using the entire truss, the whole truss with all the loads acting on it. That's what you use before you cut it and take a free body diagram. You solve the reaction forces prior to cutting. But let's go ahead and use this free body diagram up here on the right hand side so I don't have to compute my reaction forces. Something you may want to do if you have time on a quiz, time on a test, and you want to go back and check, you could come back and find your reaction forces, solve for your members, forces in each member here, and then compare to what you had at the very beginning. So if we sum our forces in the x direction here, I only have this unknown, and I didn't write my unknowns here, so let's go back and write those in. This is BA, which we're solving for, and this is BG, what we're solving for, and then I also have FG here. I'm not solving for it, but I'm going to go ahead and label it. Sum my forces in the x. I've got 5 kilonewtons plus 10 kilonewtons plus 10 kilonewtons. Those are all my x direction here. And then I have BG. And I'm going to say, let's see, is that going to be positive or negative? I have it drawn as positive, so I'm going to say plus BG times, now we know this is 4, we know this is 4, so we know that theta is equal to 45 degrees, so this is also theta. So you could say sine or cosine depending on what side you're looking at. I'm going to call it cosine 45 degrees is all equal to 0. So when I compute this in my calculator, I got BG was 35.4 kilonewtons, came out negative, so this is in compression. So we know that BG is actually going up. So if I were to actually compressing into that joint. So if I sum my forces in my y direction, then I have BA and I have FG that are unknown. So is there something else I could do in order to solve for just BA? Yes. What happens if I sum my moment about point F? Gets rid of FG, correct? What if I sum my moment about point G? I could do that, and it gets rid of BG and FG, and I would just have BA. So that is exactly what I'm going to do. I'm going to sum my moment about that point right there, about point G. So I'm not going to do this. I'm going to sum my moment about point G. So when I sum my moment about point G, I'm going to have AB, or BA, so I have it written there, times 4 meters, minus, remember that's acting in a clockwise, minus, and all these here, all these forces in the x are going to be rotating it clockwise. Now I don't need to worry about this 5 kilonewtons because it has no perpendicular distance. It's just going straight to the point. BG is the same, and so is FG. So all I have is 10 kilonewtons times 4 meters minus 10 kilonewtons times 8 meters minus 5 kilonewtons times 12 meters is all equal to 0. So calculating this, I get BA is equal to 45 kilonewtons. That came out to be in tension, and I have my 3 answers that I was looking for and that they asked for me to solve for. So there's lots of ways that you can solve for these trusses using the method of sections, method of joints. We talked about zero force members today. So take a look at this. I will also answer any questions on the discussion boards that you guys may have. All right. Thank you.